All right, so we got very interesting question here. You might try to do long division. Okay, that can work. Another method you can do is multiply 2x plus 1 on both sides. Yeah, that can work too. Um, I think, okay, let me first read the question. In the equations above, m is a constant, x cannot equal to negative 1/2. And you might ask, why do they talk about this? Well, that's because we want to be just secure that we're not dividing by 0. Okay, in case x equals negative 1/2, we are saying, hey, discard that. What is the value of m? Okay, so you know what? I'll show you both ways. I'm gonna start with the method 1. I'm not sure which one's faster actually. Why don't we just multiply 2x plus 1 on both sides? Because that's what's found in the denominator. Okay, so when you multiply 2x plus 1 on both sides of the equation, it's holding the property of equality. So we can knock this out. So on the left side, we get 12x squared plus mx plus 23. On the right side, when you distribute this, you're going to get 6x, 2x plus 1, negative 18, 2x plus 1, and the last one, 2x plus 1 cancel, leaving you only with 41. Alright, so we just do our usual, you just distribute this, distribute that, and then we're going to try to combine the like term or match the like terms. Alright, so here we're going to get 12x squared plus 6x minus 36x minus 18 plus 41. We can knock out the 12x squared. We can combine these number together. So 41 minus 18 is 23. So which means that we can also knock this out. All right, so we got mx equals 6x minus 36x, and that's negative 30x. So if you knock out the x again by dividing by x on both sides, you get m equals negative 30, and that's what they want. So what's the other way? What's the method 2? You can use a synthetic division. And the synthetic division can be worked when you have polynomial over the divisor x. And here you have a quotient x and the remainder over the divisor. But we have a 2x in front. So what I recommend is that you pull that 2 out. Because if it was just x plus 1, I would put negative 1 on top. Since we have a coefficient in front, I'm just going to pull the 2 out. And that will give me x minus, well, actually plus 1/2. Alright, so 2x plus 2 times 1/2, that will give you 1. So this is our fine. And I have 12x squared plus mx plus 23, and that's equal to 6x minus 18 plus 41 over 2x plus 1. Alright, so we're not doing anything on the right side right now, and we're just gonna first divide the top by 2. So that's going to give us 6x squared plus m over 2x plus 23 over 2 all over x plus 1/2. Again, I'm not going to manipulate the right side. I'm only going to work on the left side here. Okay, and you'll see that this is a quotient, that's a remainder. All right, so remember the rule. When you, in reality, it's x minus negative 1/2. That's why you put negative 1/2 here. But just to take a shortcut, just set the bottom equal to 0, and you get x equals negative 1/2. put it in the upper left window. Now you want to take the coefficient of the polynomial in the numerator. You get 6 m over 2 and 23 over 2. Oh, there's a third way. Third way is to use the remainder theorem. So be my guest. You can choose anything you want. When you use a synthetic division, we need the remainder to be 41. So on the right here, I'm going to put 41. Okay. So as you know the rule, as you drop 6 down, you just drop 6 down. And when you have this diagonal, you multiply. 6 times negative 1/2 will give you negative 3. And m over 2 minus 3. Okay. Once you get that far, you're going to multiply that. But we don't need to go that far because we already know that the quotient is 6x minus 18. So I can just simply set this equals 6 and negative 18. Okay, and that 41 is the remainder. So when you set these equal to each other, I'm going to highlight the part we're going to set equal to each other. That's m over 2 minus 3 equals negative 18. So if you add 3 on both, you're going to get m over 2 equals negative 15. And when you multiply by 2, you get m equals negative 30. So there is a second method